Chapter 11, Section 3, Perimeters and Areas of Similar Figures. The areas of similar polygons theorem says that if two polygons are similar, with the side lengths of corresponding sides in the ratio of a to b, then the ratio of their areas is a squared to b squared. The ratio of the perimeters is the same as the ratio of the sides, which is a to b. The first example says the ratio of corresponding sides of two similar hexagons is 3 to 2. Find the ratio of their perimeters. Well, I know that the ratio of the perimeters is the same as the ratio of the sides, so it is also 3 to 2. B asks us to find the ratio of the areas. I know the ratio of the sides is 3 to 2, so I know that if I square both 3 and 2, that will give me the ratio of the areas. When I do that, I get 9 to 4 as the ratio of the areas. The next example says a rectangular tablecloth is 60 inches by 120 inches. A rectangular placemat made from the same cloth is 12 inches by 24 inches and costs $5. Compare the areas of the placemat and tablecloth to find a reasonable cost for the tablecloth. The first thing that I need to do is set up a ratio of what I am given, which is the side lengths. I chose to set up a ratio of 60 to 12, the shorter sides of the tablecloth and the placemat. You could also set up this ratio as 120 to 24, which would be the longer sides of the tablecloth and the placemat. Either ratio that you set up can be reduced to 5 to 1. Now that I have the ratio of the sides, I need to find the ratio of the area. This makes sense because the price of a tablecloth and the price of a placemat is going to be based off of how much fabric you need to use, which would be the area of each. So to find the ratio of the area, I need to square both 5 and 1, and when I do so, I get the ratio of the area to be 25 to 1. Now that I have a ratio of the area, I'm ready to set up a proportion to find a reasonable cost for the tablecloth. So use 25 over 1 and set that equal to x over 5. X would be the cost of the tablecloth and 5 is the cost of the placemat. To solve a proportion, we cross multiply, so I need to do 25 times 5 and x times 1. So x is going to equal $125. That would be a reasonable cost for the tablecloth. The next example says that a store sells trampolines that are all regular hexagons. One trampoline has a side length of about 4.5 feet and an area of about 52.6 feet squared. Find the area of a trampoline whose perimeter is 67.5. If you notice, before I can set up a proportion of my side lengths, I first need to change the second hexagon from a perimeter to a side length. To do so, because it is a regular hexagon, I can divide the perimeter by 6. So 67.5 divided by 6 gives you a side length of 11.25. Now I can set up a ratio of side lengths. One trampoline has a side length of 4.5. My second trampoline has a side length of 11.25. Now that I have the ratio of the side lengths, I need to change that to be the ratio of the areas. Remember to go from side ratio to area ratio, I need to square both 4.5 and 11.25. When I do so, I get 20.25 over 126.5625, and I'm going to set that equal to 52.6, my known area, over x, the area of the second trampoline. Again, I need to cross multiply. When I do so, I get 20.25x equals 6,657.1875. Divide by 20.25 on both sides, and you find the missing area to be 328.75 feet squared. The next example says two similar polygons have perimeters of 7 centimeters and 28 centimeters respectively. Find the area of the smaller figure if the area of the larger figure is 48 centimeters squared. I'm given the perimeters of two polygons, and I can set those up as a ratio, 7 to 28. If you notice, 7 over 28 can be reduced. 7 goes into 7 one time, and 7 goes into 28 4 times. This would be the ratio of the sides, or the perimeters. Now I need to find the ratio of the area. Remember, to do so, I square both 1 and 4. Well, 1 squared is 1, and 4 squared is 16. So the ratio of the areas would be 1 to 16. Now I'm ready to set up a proportion to find the area of the smaller figure. So 1 over 16 equals x over 48. X is the area of the smaller figure. 48 is the known area of the larger figure. Go ahead and cross multiply. You get 48 equals 16x. And when you divide by 16, you find that the smaller area is 3 centimeters squared. The assignment for Chapter 11, Section 3 is on page 679, numbers 1 through 21 and 25 through 27.